Thank you for joining me and welcome to Chapter 9. So in Chapter 9, we're going to be taking a turn here, and now we're going to be talking about mathematical patterns. Now, the emphasis of today is really discussing what is a sequence, and then what are the two ways we can represent a sequence, okay? So that's what I need you to be able to do for me by the end of this video. A sequence, pretty basically, is just an ordered list of numbers. So it's just a pattern in numbers. And we're going to be looking for how we can represent that pattern. To represent each individual term, we use A1 is going to be your first term. A2 is the second term. A3 is the third term, so on and so forth. A to the nth term is the nth term, obviously. Now, some things can start happening because we can also maneuver around that nth term. So if you want what's previous to the nth term, that's going to be a n minus 1. If you want what's after the nth term, that'd be n plus 1, okay? So some of that notation can get a little bit getting used to. But essentially, an is some unknown future term, but then n minus 1 would be the term before that unknown term, and plus 1 is the term after our unknown term. Okay, and you'll get more familiar with that notation as our chapter progresses. So let's jump right into the big idea. So I already noted this. There's two ways we can represent these patterns, and that's the focus of today, okay? The explicit formula. The explicit formula describes the nth term using the variable n, okay? So here maybe you even want to change that using the variable n. In these formulas, we're going to treat n as a variable. N is basically going to be our x when it comes to writing these expressions. It's written based on the position of the term in the sequence. So all you have to do is if you have an explicit formula and you're being asked to find a specific term, all you have to do is plug in what the position is. So here, a sequence has an explicit formula of 3n minus 2. What are the first 5 terms? Well, the first term, I'm literally just plugging in 1 to that formula. 3 minus 2 gives me 1. If I want the second term, I'm just plugging 2 in. Oops. 6 minus 2 equals 4. If I want the third term, I plug 3 in. 9 minus 2 gives me 7. I want the fourth term. 12 minus 2 gives me 10. If I want the fifth term, 15 minus 2 is 13. We can even jump up. Let's say I have this explicit formula and I want to know what A12 is. Well, all I have to do, plug in 12 for n. 144 plus 3 gives me 147. So finding any term is super simple when you have the explicit formula, okay? All you have to do is plug it in, just like you're dealing with a normal equation, all right? The little more difficult piece is what if I ask you to write it for me? What if I'm asking you to write me the explicit formula? Oh, excuse me. Well, when I'm asking you to write one, you need to compare it to compare each number to its term or to the term it is in the sequence. So what that means is if I want the explicit formula here, this is the first position, second position, third, fourth, fifth, so on and so forth. And I'm going to compare this list of numbers to that list of numbers. What am I doing to 1 to get 2? What am I doing to 2 to get 4? What am I doing to 3 to get 6? And what I think you'll notice pretty quickly is you're just taking whatever the n value is and multiplying it by 2. Okay? So that's how we get these explicit formulas. I look at whatever its position is, and then I look at what am I doing to that position. Same thing here. Let's label this out. 1, 2, 3, 4, 5. What am I doing to 1 to get 5? What am I doing to 2 to get 6? What am I doing to 3 to get 7? And I think what you're going to notice is all I'm doing is I'm taking that position and I'm adding 4 to it to get the term itself. Okay, so usually this isn't too difficult. It's just getting used to that pattern recognition. Looking at the position of the term, what am I doing to it to get the term itself? All right. Now, this one is a little bit harder, okay? What do I do to 1 to get 0, 2 to get 3, 3 to get 8, 4 to get 15? Now, looking at all of these numbers, the 0, 3, 8, 15, 24, because I'm very math-minded, I see a pattern already. For you guys, I'm going to give you a little help, okay? Oh, almost started writing it wrong. Look at how close they are to those numbers, okay? Those numbers should be very familiar to you after doing chapter 6, okay? Those are the perfect squares, okay? So I'm just taking the position and squaring them. But then ultimately, how am I going back to get these numbers? Well, after I square n, I'm taking 1 away from it again. So sometimes there can be 2 steps involved in these processes. You just have to look for the basic patterns, basic operations, and sometimes I'll throw scoring in there, something like that, but just nothing too complicated, but look for the pattern that it's fitting. All right, so that's explicit formulas. Oh, well, sorry. There we go. All right. What about recursive formulas? So recursive is the other type of formula. And what it does is it presents it in terms of what are you doing to the previous term to get the next term. All right. So there's always an initial condition. They always have to tell you what the first term is and then give you the formula in terms of n minus 1. Okay, so an explicit formula is in terms of n. A recursive formula is in terms of a to the n minus 1. It's in terms of the previous term. So it wants to know what are the first 5 terms in the sequence. With the recursive formula, a1 is 2, and then an is a n minus 1 plus 5. Well, it gives me the first term is 2. All right. So for the second term, what's it telling me to do? So let me take the previous term and add 5 to it. So 2 plus 5 gives me 7. How do I find the third term? Well, I have to follow the same pattern. Take the previous term and add 5 to it. How do I get the fourth term? A to the 4. Well, same thing. Previous term plus 5. And what about the fifth term? Same thing. Take the previous term and add 5 to, oh, that is not good math, and add 5 to it. So recursively, you're always dealing with what is my previous term, and so what do I have to add to or subtract, whatever to it, to get to my next term. That's the key to recursive things. You're always influenced by whatever your previous term was. Now, be aware, the hindrance of using recursive is explicitly I can just find an immediate term, right? If I'm dealing with recursive, I have to start with a first term and then work my way up, okay? So if I want the fourth term, I need every term leading up to it, okay? Because I always need the previous term in order to do it. So here, A1, it gives me, is 5. And what am I doing? Well, to get my next term, I take the previous one and I add 2 to it. Same thing for A3. Take the previous term, add 2 to it. Fourth term, same thing. Previous term, add 2 to it. And there is my term, okay? My fourth term is 11. All right, so that's one of the subtle differences between explicit and recursive. Recursive, to find any term, you need to start at 1 and just work your way up to whatever you're talking about. All right, so how do you write one? Well, you always start with the first term, okay? So here I'm starting with A1 being 4. And now I need to see, how does each term compare to the term before it? So now I'm looking, what am I doing from term to term to get to my next one? Okay, so here again, look for the 4 basic operations. Okay, so here I'm adding 3 each time to go from term to term. So how do I write that? Well, I take my previous term and I'm just adding 3 to it. So remember, recursive terms or recursive sequences are always in terms of n minus 1. Explicit are always in terms of n. Well, what about this next one? Well, I'm starting with 3, and now I need to see, what am I doing to go from term to term to term? Well, this time, it looks like I'm multiplying by 2. How do I represent that? Well, I'll take my previous term, and I just multiply by 2. Okay, so actually, I think they're pretty easy to write. The thing you just have to absolutely remember is to write it in terms of n minus 1, and then do whatever you need to do between the terms. Okay? So, now, sometimes the number you're adding, subtracting, multiplying, dividing, sometimes it varies. Notice these were consistent. Okay, so it was really easy to write when those were consistent. But when those are varying themselves, then I'm going to have to start using operations in terms of n. Let me show you what that means. Okay, so here I'm adding 4, adding 9, adding 16, adding 25. So what I'm adding is varying every single time, right? Is different what I'm adding every time. So what that means is what I'm adding is changing based on n. And I think here you can even recognize that is n squared that I'm adding every single time. So my first term is 1. And then how am I going between terms? Well, I'm adding n squared between terms. So that's the key here. When whatever you're doing, adding, subtracting, whatever, is varying, you need to write that in terms of n. Okay? What about this one? Well, here, I'm multiplying by 2, multiplying by 3, multiplying by 4, multiplying by 5, multiplying by 6. So what I'm doing is I'm multiplying by n. So I'm taking my first term And what am I doing to it? Every time I'm multiplying by n. Okay, and again, you know to do that when whatever you're doing is varying. All right, so that's my key for you in how to write these recursive formulas. All right, so let's take a look at this one. The number of blocks in a two-dimensional pyramid is a sequence that follows a recursive formula. What is a recursive definition for this sequence? Well, first, let's write out what the terms are. Okay, so there are the terms of my recursive formula. Now, it doesn't look like multiplication is happening here. So let's look at adding. I add 2, I add 3, I add 4, adding 5, adding 6. So my adding is in a pattern, okay? And remember, whenever it's varying, you're talking about n. So what am I really doing here? Well, what I'm doing is I'm starting with one block, then I'm taking however many blocks I had before, and I'm adding n to it. Because remember, what I'm adding is varying, so I need to represent that with an n. Okay, so I'm adding n to the previous term every single time. All right, so a lot of good stuff here. All right, so here's some ideas of what you can discuss in the summary for me, okay? Discuss the differences between explicit and recursive formulas. I want you to discuss, how do you know to form each one? When is it better to use each one? There's a lot of things to talk about and the differences between these, and I want you to have that conversation, all right? So fill out your summary for me, please, and then come back ready to do your practice work.